This video is going to have two parts to it. I'm going to finish reviewing the practice problems in Unit 4, Section 7 on Desmos. So Desmos, there were a ton of problems that we could just practice to get used to it. So I'm going to go through each one of those. And then I'm going to go over the practice problems that are on Canvas. So there's a lot in this video, but it's just designed so that you can better understand a tricky section. So let's look first at this problem. When we're doing problems like this, we're not so worried about the number line yet. The number line's there just to help us. What we really want to do is make sure we understand the problem. So it says, the gas tank in Dad's car holds 12 gallons. The gas tank in Mom's truck holds 50% more than that. How much gas does the truck's tank hold? So we're going to start by deciding what information in this is important. We know the 12 gallons is important. The 12 gallons is how much is in Dad's car. Then we know that Mom's truck holds 50% more than those 12 gallons. So that's 50% more than that. Then they're asking us to find how much gas does the truck's tank hold. So in green, I'm highlighting either what we know or what they're asking us to find. So the first thing is this 12 gallons. This is our original amount. This is what we're starting with. The original amount is always represented as 100%. It's our whole amount, our starting value. So on my number line at 100% here, we're going to put in the 12 gallons. That's where we're starting. The gas tank in Mom's truck holds 50% more than that. I'm going to take this 50% more and just talk about one thing that is a review. But if I knew my original amount, let's say my original amount was 100%, and I have 50% more than 100%, that more means we are adding. So we're going to add 50% to that. And 100 plus 50 is 150%. So Mom's truck is going to be at 150%. So we need to figure out what value is that 150%. Okay? There's a couple ways to do this. We're going to do it using the number line first, but we could also use an equation. Okay? But I'm going to just start out. Let's figure out how much 50% of 12 is. Well, 50% divides my 100% up into two even intervals. So 12 divided by 2 is 6. So every 50%, we increase by 6 units, or 6 gallons in this case. So if we go up one more 50%, we go up 6 more. 12 plus 6 is 18. So that means that Mom's truck holds 18 gallons of gas. Now, I'm going to show you another super secret way to do this. If we have 12, and we know that the car is 150% times that, or 150% larger, we're just going to multiply 12 by 150%. So technically that would be 150%. But we don't like that. We like to change our percents to fractions or decimals if we're going to work with them. And when we multiply that out, we know we get 18. This next one says, at a movie theater, the size of the popcorn bags decreased by 20%. If the old bags, old means original, held 15 cups of popcorn, how much do the new bags hold? So, our original amount, or let's go over what we know. We know we are decreasing the size by 20%, and the old bags held 15 cups of popcorn, and we're trying to find the size of the new bags. Okay, so there's a couple of things we usually need to know, or that we either are trying to find. We have our original. Okay. We have the new, and then we have the percent. So the original, they actually give this to us. The new thing, that's what we're trying to find. And the percent, it's a 20% decrease. So that is what we know. So the original is always 100%. That's where we're starting. So we have here 15 is where we are starting. Now we are trying to find the new one. We know the new one is found by having a 20% decrease. So if we decrease by 20, that means I have 100%, and I'm decreasing, that means subtract, by 20. That is 80%. So 80% is where our new popcorn size bag is going to be. So what we're going to do is we're going to figure out how many increments we have here. Each 20% increment will increase by the same amount. So whatever this is to this, to this, to there, and then to 100. Well, we have 1, 2, 3, 4, 5 increments. So if we just take 15 and divide by 5, hopefully we all know what 15 divided by 5 is. That's 3. That means each increment increases by 3. And we can do that by checking. We can check and see if we did it right by looking and seeing if the increments are evenly spaced. And they are, so we're good. So then we look at our table. Shoop, there we go. And that means that the new popcorn bag holds 12 cups. Okay, now the super quick, easy, short, secret way to do these. And the only reason I'm going over this is the next section, section 8 and 9, are going to look at this way, or the secret way. But really what we had is we take what we started with and we multiply it by our percent, 80%. So we're going to go 80 over 100. And if we multiply that out, you would see that you also get 12. Let's go on to the next problem. A school had 1,200 students last year and only 1,080 students this year. What percent was the decrease in the number of students? Okay, this is a really good question because it's not asking for the old or the new value. It's asking for the percent. And they're asking for the percent decrease. So we had 1,200 students last year. That's my original amount. That's where we started. And then 1,080 students this year. So let's go find those on our number line here and here. So we really want to just figure how much are we decreasing? What percent? Now, we have 1,200 was last year. This is our original amount. 1,080 is our new amount. Okay, so let's go ahead and say then our 12,000 is 100% because the original amount is always 100%. Let's look at how many increments we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 increments to get to 100. So 100 divided by 10 is 10. So that means each dot represents 10%. So we've got 10%, 20%, 30, 40, 50, 60, 70, 80, 90%, 100%. I just didn't write all my percents in because I was going to be way too small. So if I want to figure out how much I'm decreasing to go from 100% to 90%, we subtract them and we have 10%. That means that going from last year to this year, it is a 10% decrease. Okay, this problem follows that same pattern. 1 week, gas was $1.25 per gallon. What a dream. That'd be amazing. The next week, gas was $1.50 per gallon. By what percent did the price increase? So we're going to take a look. We started with our last week, or the first week was $1.25, and then the next week was $1.50. So $1.25, that was my original, or my 100%. And this next week, this is my new amount, and we don't know the percent increase. That's what they want us to find. So we know at 125, that's 100%. And we need to figure out how much it increased going to $1.50. So if we look at our increments, we have 1, 2, 3, 4, 5 increments. So we're going to take 100, divide by 5 is 20. So that means each increment is 20%. So I'm going to write those in. 80%. And then if we keep going, we got 100%, then 120%, 140%. I'm just adding by 20 every single time. So the amount of increase here, we went from 100 to 120, so that would be a 20% increase. There we go. All right, we're going to try something even more new with these problems. This one's a little bit tricky. I think these are the trickiest ones. After a 25% discount, the price of the t-shirt was $12. What was the price before the discount? So we know we have a 25% discount, and the t-shirt after the discount was $12. We want to know what was the price before the discount. Okay, so what we have here, that is our percent, in this case decrease, because it is a discount. We have the price after the discount was $12, so that's our new price. They want us to find the price before the discount. That was the original price. Okay, so let's put those on our double number line. Okay, ooh, that's actually kind of tricky to do. 100%, that is what we are trying to find. That's what we don't know, but that's what we are trying to find. So this is our original. We're trying to find that. Now, we need to figure out the discount. So here, a 25% discount means that if I had 100% here, a 25% discount would be 100 minus 25. We are paying 75% of the price. So my new amount was 75% of my original price. So the value that goes with that is 12, because 12 was the price after the discount. Now, if I look at my increments and I have 1, 2, 3 until I get to what I know, if I divide 12 by 3, we get 4. So each increment, each 25% increment is 4. 4, then we add 4 more is 8. 8 plus 4 is 12. Then 12 plus 4 is 16. 16 plus 4 is 20. Okay, so we kind of fill in our double number line. And when we do that, we get that at 100%, the price was $16. So we know then that the original price was $16. This question says, compared to last year, the population of Boomtown has increased 25%. The population is now over 6,600. What was the population last year? So the information we know. We're comparing to last year, so last year is our original. That's our 100%. Okay, and then the population has increased. So increased 25%. So if we have 100%, we are increasing or adding 25% to it. So that means our new population is 125% of the old. The population is now 6,600. What was the population last year? So 125% is what we know. We know that is 6,600. We want to figure out what is the population at 100%. That's what we need to find out. So I'm going to figure out the amount of increments I have. 1, 2, 3, 4. There's 5 increments of what I know. So I'm just going to go 6,600 divided by 5. And what we get is 1,320. So I'm going to write that. An increase of 1,320 each time. So this would be 2640, 3,960. Then I add 1,320 again. I get 5,280. And then add it one more time. We finally end up at 6,600. So we know then at 100%, our population was 5,280 people last year. Okay, we've got two people that have two different number lines for the same situation, and we've got to try and figure out which one of them is right. So it says a juice box has 20% more juice in its new packaging. The original packaging held 12 fluid ounces. How much juice does the new packaging have? So we know our original, that's 100%, and that 100% is 12. So we've got that one down. Then the next one we know is that the new packaging is 20% more. So if we were at 100%, the new packaging is 20% more. We end up being at 120%. Okay, so we can look at both of these number lines and say, okay, Priya actually put her original amount at 100%. So we already kind of know she's the right one here. Okay, Claire put her original her 12 at 80%. So that doesn't actually work because 80% is not the original. The original is 100%. So without doing any math, we already know who has set their number line up. Priya is correct. Okay, because they put the 12 on the 100%. All right, those are all of the questions that are on the Desmos. So now we're going to go on to the practice problems. Okay, so the first practice problem says that a bakery used 25% more butter this month than they did last month. If the bakery uses 240 kilograms of butter last month, how much did it use this month? So the first thing I'm going to do is I'm going to draw some double number lines. Okay, and I know that I have 100% is going to be how much we're starting with last month. So last month, that was my 240 kilograms. And we'll be nice to ourselves, we won't put the unit there. Okay, now the bakery uses 25% more this month. So we're going to add 25% to that. That's 125%. So now on my number line, I'm going to put a 125%. So we know, and we can actually solve this problem without filling the whole number line out. And I'm going to do that now, and then we'll do the number line. But essentially, we are trying to figure out what 125% of 240 is. So I'm just going to go 240, and I'm going to multiply by 125 per 100. So if we go and do that, we get 300 kilograms of butter. Okay, so really what that means is on my number line, that would be 300 there. Another way to look at this with our number line, we are increasing by 25%. So if we can figure out 25% increments, let's start 0, 25, 50. I know those aren't evenly spaced, but if we can figure out these percent increments, then we could also solve the problem. So 100 was 240, and we're breaking 240, and we're breaking 240 up into increments. This was 0. We would, 0. Then we would have 60, and then we would have 120. Then we would have 180, and then we would end up with 240. And then if we added 60 again to the 240, we would end up with 300. So I personally think the double number line is a really good visual way to see it, but it is also the longer way to do these problems. The good thing about the double number line also is it is pretty helpful if we're going backwards from what we had. So I'm going to put my answer in there, 300 kilograms. Let's go on to the next one. So it says last week, the price of oranges at the farmer's market was $1.75 per pound. This week, the price decreased by 20%. What was the price of oranges this week? All right, so we have here, we are at 100%, and then we are decreasing that by 20%. All right, don't see that too often. So if we decrease by 20%, we are now at 80%. If we look at our double number lines, we have 100%. The 100% was my original, so that's $1.75. Okay, we're decreasing by 20%. So let's make our 120% increments. So we would have 20%, 40%, 60%, 80%, 100%. All right, so if we break these up into 1, 2, 3, 4, 5 increments, then what we're going to do is we're going to also divide our 175 up into 5 increments. That gives us 0.35 for each increment. So I'm going to line them up. My first increment would be 0.35. My next increment would be 0.70. My next increment will be 1.05. My 80% increment would be 1.40. And my $1.75 increment is at 100%, so we're good. So then we know we're only paying 80%, so let's look at the price for 80%. Here we get $1.40. $1.40 per pound. Now, the other way to do this, once we get that without having to do all the increments and all the breaking up, is we know we're paying 80% of the product. So if we just take 175 and multiply it by 80%, which is 80 over 100, we also get 140. Okay, so this question's kind of weird. It's going to take some critical thinking, but it says, Noah thinks the answers to these questions will be the same. Do you agree with him? He says, this year, a herd of bison had increased by 10% in population. If there were 550 bison in the herd last year, how many are in the herd this year? So there's our first question. Then the other one was that this year, another herd had a 10% decrease in population. If there are 550 bison in the herd this year, how many bison were there last year? Okay, so we need to go ahead and look at this. The big part is knowing the original value. If the original value is last year's herd, 550 bison is the original value here. And on the second question, we're trying to find the original value. That means that we are going to increase here, and last year, to get from this one to what we had this year, it's a decrease. So it's not really working out. Our original values are going to be different. A 10% increase to 550 is different than a 10% decrease to get to 550. So both of those do not work out. You should disagree because the original values are not the same. And one thing you could do is we could actually calculate this out. So let's look at herd 1. And I'm not going to draw the picture because that might take too long, but we have 550 bison in the herd last year, but we have a 10% increase. So we're going to multiply by 110%. And we end up with 605 buffalo or bison. Herd 2, there's actually going to be some math in here that we haven't quite seen yet, but it's okay. We have our original value, we don't know what that is, and we are decreasing the population. So that's 90 over 100. That equals 550. So what I want to do is I want to take the 550, and instead of multiply, I'm going to divide. I'm going to go 550 divided by this, and we get 611 buffalo. So the amount of buffalo does not end up being the same. Okay, this question is a review question from section 2 and 3. It says, Elena walked 12 miles. Then she walked 0.25 that distance. How far did she walk altogether? Pretty sure that's supposed to be did. Hopefully I'll remember to go fix it before you take the quiz. All right, let's use that bar or tape diagram to represent this. So this was our original amount. And then she walked a little bit extra from that. So if this was 12, her original amount, she walked that, and then she also walked 0.25 that distance again. So we've got to multiply the 0.25 times 12. So we can go and find one of those options that will work. We want to decide if any of these other options could possibly work. Well, if we use the distributive property and I factor that 12 out, I have this. And then also I can add 1.025 time together and we get this one. So we've got this option and this option also are options that work out. Okay, our next question says, a circle's circumference is 600 meters. What is a good approximation for the circle's area? Ooh, this is a question that on our circle test we really struggled with. So if I've got a circle, their circumference is the diameter times pi. So if my circumference is 600, that's the same thing as my diameter times pi. Well, if we want to undo multiplying by pi, we can just take our diameter and divide, or our circumference, and I'm just going to divide it by pi. And we got that my circumference across is about 191. Okay, from there, we want to find the area. If we recall, area is equal to our radius squared, so our radius times pi. So I'm going to find my radius. I know my circumference is 191, so my radius is just half of that. So I'm going to just round this. I'm going to say 191, let's say divided by 2 is 95. That's my radius. So then we're just going to go 95 times 3.14. And I calculated it out. I got about 28,338.5. Now that's a super approximation. I rounded a lot. So I'm just going to go find which one of those numbers is the closest. That's close to 30,000. So there's our close approximation. Okay, this question is also a review. I really like this because it's going to help us do some things in the next couple units. It says, the equation d equals 3t represents the relationship between the distance in inches that a snail is from a certain rock and the time t in minutes. So d equals 3t. The d represents the distance, and that equals 3 times our time. So we can use this formula to find different components of the problem or the situation. The first question asks us to say, how many minutes does it take the snail to get 9 inches from the rock? Well, in purple, we'll do this one here. It says if our distance is equal to 3 times t, and we're trying to figure out how long it takes to get 9 inches from the rock, I'm going to put 9 in for my distance because 9 inches is a distance. So what I want to do is I want to figure out how to solve this problem. You can either think about it and solve it, or you can actually do some math to solve it. If we have 9 equals 3 times our t, to undo this multiplication, what we do is we just divide both sides of my equation to cancel that out. So 9 divided by 3 is 3. So that means it takes the snail 3 minutes. The next question says, how far will the snail be from the rock after 9 minutes? So how far is our distance? And after 9 minutes is our time. So we know our time. We are trying to figure out our distance. So our distance is equal 3 times 9. Well, that's pretty simple. We just multiply those and we get 27 inches. All right, so that was it. That whole section is mainly involving increasing and decreasing our percentage, but there were a couple bonus questions that were reviewed. So good luck. If you have any questions, feel free to email me.